So we are live. Okay, hello everyone. So I am Blazon Lai. I am a student. I am applying to hopefully either Oxford or Cambridge. Now I know that the person watching this is probably going to conclude that it's going to be Oxford because I, like the dumb little idiot that I am, have put Oxford on the title. I haven't actually made my decision yet. I might lie on my personal statement and say, "Oh, it's been my life ambition." I haven't decided yet. They're basically the same thing, anyways. So. I went ahead, I looked at the Wikipedia article for Oxbridge, and it turns out in order to get in for computer science, which is the thing that we are doing, we have to do a test of mathematics. It used to be the MAT, and even this hasn't reflected it yet. So you say, oh, Durham or Lancaster or Warwick. No Oxbridge, but Oxford has just changed to it to require the TMUA this year, and so we need to obtain a 9. It's somewhere here. Come on. Yes, we need to obtain a 9. So it works like GCSE, where a 1 you should fail, you fail, just why have you bothered? And a 9 you instantly get in. I'm pretty sure this is how it works. I didn't ask anyone on this, but come on, right? It's a 9. 9 is good. We like 9s. 1s are bad. We like 9s. 9s get you in. So, here is the past paper. It is what we have so wonderfully also put on the thumbnail. It is the specimen paper, paper 2. So if you take a look at here, paper 2 has multiple choice questions. It has 20 of them, 75 minutes. It assumes knowledge of the GCSE curriculum, so fairly easy for those Americans watching. And it assesses a candidate's ability to justify and interpret mathematical arguments and conjectures. Basically, is something the truth? We are supposed to determine this. We're supposed to determine if we can prove something is the truth. I don't know if we will be able to do this, but I'm very intelligent, so we shall see. So I've got this right here. I've got our lovely OneNote set up right here so we can write on it. We've got the specimen paper one, which was a test stream that I did earlier. It went pretty terrible. I got what did I do? I got 13 out of 20, which yeah, it's alright. So the problem with the specimen papers is that we don't know how well we did because 13 out of 20, we can do the math here. It is a 65%, which you might think, oh, this directly correlates to 1 or 9, but actually the grade boundaries are curved something every year. So since the specimen papers didn't have an actual audience to take them, we don't know how well we did, so we're forced to just guess. I would say 13 out of 20 though is meh, it's pretty bad. I'd say it's somewhere around maybe a 5 or a 6 because this is rather one of the easier papers, I'd say. Definitely the much easier than 2016, which is the other paper that I did. And as you can see here, I got 2 questions wrong at the start, got all of them right, and then proceeded to mess up all of them. And this pretty much follows the same exact format we'll be doing today. So we'll do all the questions, and then we'll mark all the answers, and we'll try to write down some advice for myself to follow later on. Okay, enough talking. Without further ado, here we begin. Actually, no, we're doing a sponsor break. No. Okay, so, right, M8, no. TMUA build, how do I split screen this in such a way that I can see the time? Okay, so we are doing, where should I put this? Right, here's good. Yep, here we go. Okay, so, well, without further ado, 1, 2, 3, go. Okay, so first question, switching this into writing mode. Right, okay, let's see. Okay, right, we're pausing this. Okay, so first problem that I spotted while doing paper 1 is that OneNote has so geniusly decided to remove the feature that allows us to have a pen bar at the top. What this means is that this thing has to be done like this. You have to make it go full screen, and then you have to full screen it. You have to get full screen and then full view it and then summon the pen bar and then make it go sideways. And that's the only way that it can appear. So I'm going to reset my timer because I haven't read the question. And we're going to begin again in 3, 2, 1, go. So the radius of a circle is a funny number. So this is pretty simple. We can just begin by rearranging this, and then we can complete a square. So I don't really remember how to do this all that well. So we square this, and then we 2 Why? So I am skipping some steps. I will be skipping a lot of steps throughout the entire thing. Apologies if any viewers hate it when I skip steps. Have you tried coping? Okay, in all seriousness, it's a TMUA. Come on, man. Just have some lower expectations for my tiny brain. Okay, so once we do this, then it's 16 plus 16 minus this. So this is, I do this. This is 13, which equals to D. So I'm pretty sure that I've done something wrong-ish. I don't really trust myself, but we are gonna leave this for now. Aha! I found it. Okay, so we factored the 2 out, but this is actually supposed to be divided by 2, so this is actually 4. This is supposed to be 3. And this is supposed to be 9 because that's squared. Okay. And so therefore it is actually, aha, I knew the number was too big. So it's actually negative 4, 15, 4, 9, 15. So we can then reverse it because we're throwing it over to this side. And that's a 9. So that's 13 minus 5. So that's negative 2 square root, which doesn't make sense. Okay. So we've done something horrendously wrong. Yeah, yeah. Um, let's see. Okay, so we have 3 minutes, 1 more minute to work this out. We should have done most of this correctly. Okay, so I'm gonna use a special technique, which is we're going to redo the entire question from scratch because I cannot be asked to figure out what the hell was wrong with my original working. So we're doing this, and then this time we're not gonna skip steps because we've learned our bloody lesson. Look, I always get stuck on these first questions, right? Because the first questions have the unique factor of being this is 8. Because you have to multiply this by, oh my days. Right. I always forget these basic techniques because I haven't done these in forever. So this is actually, no, I've just copied out the entire thing. Okay, my time isn't looking great, but whatever. This is squared. This is negative 9. This is negative 18. I hope. So therefore, if we extradite the thingamajig, so it looks like this, which is 11 square root. Hmm. Oh, because the 2 gets flung over there, right? So this becomes 11 times this nonsense. And then 11 square root. And then you divide this by 2 to make it just just the square bits and your square root. Okay, so the answer is B. Right. Okay, so moving on, that wasn't very efficient. The gradient of the curve is y equals this mess, where x equals square root 2. Okay, so we know for a fact that the good gentlemen at the Oxford thingamajig are too lazy to add questions which require actual thinking. So the only method of differentiation we are allowed is the easy ones, so we can just use the power rule for this. So it's not too difficult, it's not too mentally challenging for a prodigy such as me. Right. This examiner working, it looks reasonably correct so far. Okay, so we are differentiating this into one is one of two. Right. So then this is negative. This is negative, and we are making this into 6. And then this becomes this. And then this is positive because 2 negatives, and then this is 2x, and then this. So that's differentiated. And now we plug in 2. So we plug in 2, it becomes something like this. And then it becomes something like this. And then since this is also negative, so we're plugging in something like this. Yes, okay, and now we need to solve this. So, okay, so this is fairly easy. This is just 9 square root over 2. This is 4 square root 2. 4 square root 2, which simplifies. And then this is something not dissimilar. This simplifies to this. So now this is all 2 root 2, so 9 minus 3 plus 3 cancels out. So now it's 9 over 2, which is then D. Okay, so we are slightly off track, but we'll keep going at speed. Consider the following attempt to solve an equation, and we've got a nice little equation. We put a bunch of steps into it. Okay, so it could be all true, it could be neither is true, it could be one is true, and then the error could be in step 1, step 2, or step 3. So let's look at this. So we take the square root, we shove it over there, square root it, do a bit of the minusing, and okay, so this, using the cross method, we can determine step 3 does hold out, step 4 holds out, so it's either... Okay, so let's just brute force, right? So if we plug in this, we can know that it's negative 1, and this is 1, and this is always positive. So we know that x equals negative 4 is always false. Yep, so it's the wrong answer. So if we plug in negative 1, which goes something like this is 2, this is square root, and so, okay, so it's C, D, or E, and we can figure out which one is wrong. Hmm. I reckon it's got something to do with... Okay, step 1. I think it's fairly straightforward, right? It's not going to be a calculation error, that I know for sure. It's going to be some kind of finicky gimmicky. Yeah, off the gut instinct, off just sheer gut instinct, I'm saying it's 1, and I'm saying it's C, because 2 and 3 seem pretty seem pretty obviously correct. So I'm gonna do some, yeah, I'm just gonna say that's correct. Okay, here seems something easy. Here comes something easy. We've got some cards. We've got A, B, C, D, E. We've got numbers. Which of the following provides a counterexample? Every card has a vowel, has an even number. Wow, this is easy. A or E. So it's A. Seriously? Alright. So using the observation that these two are kind of the same, it is possible to deduce that log is approximately... Okay, so if we write this as x, and then we say that 3x is kind of equals to 2, oh, this is difficult. Oh, this is actually quite interesting. Okay, so using the observation that these two are equivalent to each other, we have to work out what log 2 is. Okay. So there is definitely some correlation. Okay, how about this? What is log 5? That is just 3, right? Because if it's 3, then it will be roughly equal to that. So from there, we can figure out. We can take the 5 out and then put it over there, and then this equals and then this equals the log 2. So therefore the answer is A. There we go. Okay, it's not that hard. Um, tricked me out for a moment there, but it'll be fine. An area is estimated to be a number. A width is estimated to be another number. Which of the following expressions gives the greatest possible height of the triangle? Oh, it's a it's not triangle. It's a rectangle. So it's a 2D shape. So therefore, we know that this is 80. This is x. And so 80x is probably equals. We want the greatest height, so it has to be something like this. Yeah, because this is the greatest possible height. So we are doing some divisions. Oh wait, this is the greatest centimeter. So we want this to be the smallest possible, so that x is the greatest. So we can throw this over here, and so x equals that, and therefore x is blah blah blah. The answer is F. Okay, we're moving quickly so far, but these are easy questions, so let's not get too overconfident. We want time to check our answers. Which of the following is a sketch? We can write this out. Weird. Very odd indeed. So I believe we can possibly do this. Can we do this? No, but then this would be 2, right? Yeah, this would be 2. Would it cancel out? No, it cancel out, would it? Yeah, it cancel out. Okay, so the xy would cancel out, so that's not a possible factorization. We can't factor this, can we? Hmm. Okay, so what's quite interesting to notice is that half these are linear in one direction, half these are linear in the other direction. So trying to multiply this out may be a bit tough. That it may be. And I don't believe multiplying it out will, gain us any kind of advantage either, because we can't extract x or y out. So we could plug in answers randomly and then see where that gets us. At the same time, I don't want to solve a cubic. So let's look at where 0 ends up. Okay, let's say that x is 0, right? Let's say x is 0. So then this becomes just y squared equals 1, which means that y equals 1. So when x equals 0, y is equal to 1. So it's B or C. And when y is equals to 0, yes, that does differentiate them. So when y is equals to 0, then it is x squared. So it's the same. So therefore x is equals to 1. Is it? Yes. So it must be C. So we can sub in 0 for x and y in order to figure this out. So next question, number 8. Consider the following statement, positive integer n. Which of the statement is true? Statement: the sum of the sum of the four consecutive integers, the smallest of which is n, is a multiple of 6. So what we are saying is n1, n2, n3. So it's true for all values of n. So what we're saying is this is divided by 6. Okay. So it's true for all values. It's true for all values which are odd. It's true for all values which are multiples of 6. Or it's not true for any values of n. So what I believe we can do here is we can actually multiply this. Actually, no. It'll be easier to do the n at the end. So let's see. So n squared 3n plus 2, and then from here it is n squared 3n squared n cubed 3n squared 2n plus 3n squared plus 9n plus 6, and then that entire chungus gets multiplied by n, which leads us to the conclusion. And okay, I'm not multiplying all that out. The point is that it exists. Then what conclusions may we draw from this? Let's see. So 6n squared, which we like, 11n, which we don't like, 6, which we don't like. Pretty easy. Okay, so yeah, this becomes this. And we can take the 6 out here, and that makes them multiples of 6. So we have to consider if these are, when does this a multiple of 6? Interesting. We're on question 8, so we're not that short for time. Statement is true for all values of n which are multiples of 6. But not for any other values of n. How can we figure this out? We could factorize it. Factorizing is always lovely. Which produces n plus 11. Okay, so we know it's not e, because when n is equals to 1, then it always must be a case. But when n is 1, so it's either a or b, because c is not for any other values of n, and d same. So it's a or b, and we can test this. We can test it. We can put 2 in, and since 2 is 8 times 13, which is most definitely not, it's probably gonna be b. We have process of elimination it, which I really don't like, but whatever. Oh god, okay. Every day next week, Fred will do at least one math problem. Okay, so every day next week, Fred will, so not every day next week, Fred will do. So on at least one day next week, Fred will not do at least one math problem, right? Yeah, that makes sense. So it's E, I hope. Okay, this is confusing. So I think I have it right, but it's well, let's just double check it anyways at the end. Which of the following is a sketch? I love sketches. Um. Oh. Oh, this isn't a hard sketch. This is just a sketch. Oh. Oh. So doesn't it? Okay. No. 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 It's the base of the logarithm is x. So let's see. How interesting. So we could turn this into 2 equals x. What? xy, which is bad. I don't like that. But as x increases, y must decrease. We know this. As x increases, y must decrease. So it's probably not A, it's not C, sure as hell ain't sure as hell ain't F. So from there, can we sub in a value? Okay. what if x equals 2, right? So then y is equals to 1, which is definably not true here. And one look at C tells me that's not the case. So yeah, it's obviously E. Okay, fine. Because only in E do you see the graph that you might actually see from that. You can sub in one value and you'll see instantly. Okay, so which of the following numbers is largest in value? So log 10 is literally just 2. So it's log 210 is like 3.2-ish. So it's not B. Sine, so that's 1. 1 to the power of 1, which is 1, which is not it. That's something like 0.4 to the power of 10, which is not it. 10, 10 looks something like this. And what you're proposing is somewhere here, right? Yeah, I hope. I do hope. Yeah, so I'm saying that's not the case. I'm saying it's probably D. I mean, I'm just guessing here, fam. I'm guessing on most of these questions. I mean, the answer is probably right, but I'm still guessing. Right. Polynomial Px has property that P1 equals 2, which of the following can be deduced? This is remainder or factor theorem. P of x equals x minus 1 qx plus 2 for some polynomial qx. Okay. God, okay, so this is remembering the factor theorem. I'm pretty sure it's A. This is just a memorization thing. I'm pretty sure it's A. I haven't made notes on all the TMUA topics yet. I'm pretty sure it's A. It could also be C, but I'm guessing it's A, and there's not really much more I can do about it at this point. This is a very easy paper. That was just recitation. It's not really problem solving, but it's a nice warm up, I guess. Five runners competed in the race. Fred and George and had more. So all Harry Potter characters except one. Okay, Fred beat George. So they all beat George. Okay, so good old George is at the bottom. So George is irrelevant to this. So we have Hermione. Please hope I pronounce that wrong. Okay, so basically, Lavender must be at the bottom. So it could be Hermione here, here, here. Hermione here, here, or Hermione here. Yeah, these are all the possible spots. So there are 6 possible spots, I believe. Though this is a tricky question, so I will say, go back to it later. The graph of the polynomial strong function is this. It's a what's it called? Quintic, whatever. It's power 5. So bunch of constants. It is not possible that it has. Ooh, that's interesting. So we're looking at the minima and maxima now. So let's draw a graph. Um. Okay, so we know that it has 4 of them, a maximum of 4 of them, right? No local minima or maxima is crazy work, though. How do you achieve that? Okay, now let's not look at the obvious, right? So it's probably gonna look something like, okay, so, okay, no, so cubic goes like this. A quartic goes like this. So quintic must go like this, right? One, two, three, four. Okay. how would it have no local minima or maxima? What does this graph look like when it's zero? Like for all of them except A? Fam. Because I swear it would still have some oscillations, right? Okay, we're very clearly proven it's not gonna be A. It's I don't think it's gonna be B or C. Those don't make sense. I feel like you can merge the two. So I'm guessing it's D. Okay, let's write down D. Let's not move on yet though. I wanna think this out. So let's see. Let's so if they are all actually to zero, A when x equals one and A is one, so we are just looking at this. It goes here, right? And if it's negative, it goes here. If it's two, then it goes here. Okay, no. Okay, that's an exact. It goes here. If it's negative, so it's still negative, so it goes here. So basically, it looks like this. So that's how it has no local minima or maxima. If it just goes like this. Is that right? That probably does look right. Shit. Okay, so that means it's not D. It's not A either. It might be B. B is the one that's really spooking it out to me, you know? Because okay, let's see. Let's construct something. So if x, let's say x plus one squared, right, and then x plus one, the x negative one, and then x plus two, and that's still only four of them. These are roots. No, but you're differentiating it. Okay, so let's assume this is what it looks like when you're differentiating it. Okay, let's put B and then put two question marks here. Let's go back to this later though. Because we can't graph that. This is not a thing we can graph. This would be like f of x differentiated. I'm sorry. So for any real numbers a, b, c where a is larger than b or larger than equal to b, consider three statements: one, two, three. Which of the statements must be true? Okay, let's consider three first. Three seems the easiest. So it's some constant. What if you multiply it by a negative, right? So what if it's negative one? So that means it's negative three bigger than negative two. Uh-oh. So yeah, that doesn't work. Three is not always true. If you multiply the damn thing by negative, on the other hand, one may be true. Because think about it, you are effectively swapping positions. You're rearranging the thing. Yeah, one is probably true. Yeah, you're just swapping them around. And two is a squared plus b squared. Um, it's larger than that mess. So this is what is effectively looking like this, right? And we can differentiate this into not different. We can factorize this into a minus b, a not a plus b. Is this a minus b squared? Yeah, I think this is a minus b squared. So it's that mess. Aha! This is where we have to consider if a equals b, then this thing equals 0. Mm-hmm. I know these things. And A must be larger than B. So therefore, and since it's squared, it must be big. Okay, so fine. I would say that I would conclude pretty conclusively that 2 is true, so we can move on. The sequences. Ooh, sequence. They give you a lovely little sequence. It's A1 equals 2, A n plus 1 equals an plus thing. So it's not that hard, really. Okay, let's model this out, right? 2 plus 2, what's n? So the second term means that n is 1, so that it becomes 1. So 1, this is 2. And then since negative 1 is 3, plus 2 is 1 again. So it's 1, 2, 1, 2, 1, 2, 1, 2. Okay, and so on and so forth. And this is 100 numbers. I know these things. Is it? Yeah, it's 100 numbers. So it's 2, 1, 2, 1, 2, 1. So it's 3 times 50. So it's 150. Which I feel like is so wrong. And on second thought, no, this doesn't seem reliable at all. What? Gang? Are we fried? There's no way. There's no way. That's too simple. Come on. Where's the trick here? Come on. Come on. What? No, they've given you E. Come on. What's this? What's this? This all looks outrageous. What is it? What? There's absolutely no way it's 150. Come on. A1 equals 2, and you're supposed to add them all together. Is there okay, sequence AN is given by the rule. This and is there like a secret third page? Is it no? I mean no? This is weird. Okay, I'm putting question marks on this. I don't two question marks because that's a weird question. Right. There's no way it's that easy. Let S be a set of positive integers. Sure. I haven't worked with sets before. The positive integer n is an S number if and only if every factor of n with m larger than 1, the number m is a multiple of some number in S. Positive integer n is an S number if and only if. For every factor m of n, if m bigger than 1, the number m is a multiple of some number in S. So 9 is an S number because the factors of 9 are 3 and 9, and each of these is a multiple. Okay, so positive integer n is therefore not an S number if and only if. Oh, so this is just a proof. Oh wow, this is easy. So for every positive factor m of n with m larger than 1. So the first bit is the same. There's a number in S. Okay, so this is just a logic problem. If for every factor m, so for every factor m of n with m larger than 1, there is a number in S which is not a factor of m. Okay, A. Okay, I'm reading through A. This seems correct. Like, I'm looking at it, it seems correct. I'm not sure if it is. Because there has to be at least one factor m which is not a multiple of a number in S. At least one. Okay, so it's not every, so it's some. So it's D, E, or F. So D is fucked, F is fucked, so it's E. Aha. Okay, so there's no number in S which is a factor of M, which is basically the same as none of them are yeah, none of them fit. So there we go. So a group of numbers is, oh, what, seriously? Group of five numbers, the mean is 0, the range is 20. Really? Really, bro? Alright, man. I mean, really, bro? You gotta do this to us? Okay. So the median, let's try some of these out, right? So let's say it's 8. Let's say it's -8. So it's 20. It's -8. It's -8. And then let's say it's like, say it's 10 or something, right? So then these cancel out, these cancel out. No, actually, this has to be in 18, isn't it? Oh, no, 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 I'm dumb. The range is 20, so actually it's -10 and 10. This makes this harder. Okay, so what if this is both -10? Yeah, wait, what if these are both -8? That would make the max number 2. Okay, so this needs to be, no, 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 wait, okay, so -8, -8, so large number is 12, so this all needs to balance out. So then we can go 4. Oh, okay, this is hard. This is tricky. It's tricky, tricky, tricky. Because this isn't a question you can approach with normal GCSE techniques, is it? Right. This is right. This is 8. For some reason, I don't think this is 8. Right. I just don't think it's 8. How would you make it so that the thing varies and then the biggest value is. What if? Okay. What if we say E minus A, where A, B, C, D, E minus 5 is equals to 20, and this is equals to 0. And then what is C? So how do we maximize C? Interesting. Okay, no, this equation isn't gonna help, I don't think. But we can circle it and say that we have it set up for now. Okay, so let's go back to reconsidering. I don't want to just brute force it. I don't think brute forcing it is the solution. It's the largest possible median, right? So they all have to add up to zero, and the difference between the biggest number and the smallest number has to be 20. How do you maximize the number under these circumstances? So what I'm thinking is the two negative numbers have to be equivalent. It has to be as close to each other as possible because you want to maximize. Because the more negative, right, that these two numbers are, then the more space you have to in the positive numbers. But at the same time, this plus 20 is the maximum that you can get. So therefore, these have to be the same essentially, which does put a nice hard cap on things. So the mean is. So I'm just trying to create something that's kind of valid, so I can take away some solutions. So the range is in fact 20. The mean is in fact 0. So this is valid. So A, B, and C are instantly out. So from there, we have to figure out some way. Largest possible median makes it 20. Okay, so it's definitely not F. That's ludicrous. It's not F. It's not A, B, or C. So it's either D or it is E. So if we make it this. Ah, this has to go to 14. This has to go to negative 14. Ah, so it's E. Okay. Ah, that's not that hard, actually. Okay, fine. Let's move on. What's the last question looking like? Okay, last question seems easier, so let's just do question 19 quickly. A, B, and C gives an equation, free roots. How do you describe them? Well, that's weird. Okay, so let's throw all of these onto the same side so that we can kind of think about them in a clearer way. So that's the first one. And this is the second one. And we know that there are three real roots. Three real roots, which we have to figure out. Or it could be it has exactly one root. So that's So we can't factorize this. Yes, we can. No, no, no. Okay. So let's say NMK. So we know that it is K is probably going to be minus, and then there's going to be some N, and there's going to be some M. So that's this. Because the roots are the factors, so we can like factorize it, kind of. So C is positive. C is positive, so it either has to be all pos or two negs. Yes. So B is out. E is out. Oh wait, these are the same. I'm a dummy. Oh yeah, so these constants are the same. We're throwing them over. Right. Actually, no, 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 no. So that's still the same. Okay. So we can still take out B and E, I think. Yes, because we know the roots. The number of roots differs depending on A, B, and D. Okay, so now we have four. No, now we have five solutions, which any could be correct. Not a great sign, gang. Okay, dead air is bad, so I'm going to keep talking while I puzzle something out. It's good Oxbridge practice, anyways. There is exactly one real root. How would that be figured out? So what are the changes here, right? A squared becomes negative, and C becomes positive. So the change has to be somewhat limited. Okay, so let's think about defining what A is, right? So A is probably gonna be XXM, so M plus N minus negative K. Minus K, yeah. Because we can figure that out by multiplying it. Yeah. So it might be kind of cooked. But I don't really see any better options, so here we go. Yeah, so that's that. B thankfully stays the same. C must be negative K M M. So by making C positive, and by making A negative, you've essentially turned it into this and this, right? I don't see how this is going anywhere, but sure, we'll continue. It has three real roots, but their signs differ. It has one real root, which is positive, which still could be the case. God, I know. If I draw a nice little graph, how about that, right? So we know that there's two negative, so it looks something like this. Mm-hmm. And so what we're doing is we are flipping the negativeness of ax squared and c. So what that would do, I'm gonna be for real, it's not clear. It's not clear to me, gang. So let's say c is up here instead. No, no, that can't be the case. It has to look like this. Otherwise, something horribly wrong would blow up. Mm. Yeah, okay. So, we've drawn this funky little thing. Let's look at C. If we make C negative, does the entire thing flip? No, it doesn't. Um, probably gets shifted up or down. So it could be shifted something like this. Whereas this was the original. Oh god, no, no, no. That's somehow wrong. Whereas this was the original. So we don't know if it's 1 or 3. Yeah, I'm gonna put G. I don't really want to spend more time on this. Let's go do 20. 20 was promised to be easy. Come on. So, of these 5 statements, an odd number are true. Both statements made by women are true. These two are women. Or my first name is Robert and Mr. P statement is true. Exactly one statement is true. Neither statement made by a woman is true. Wow, misogynist. So, this very tense conflict between misogyny and misandry can be concluded thus. My first name is Robert. How is that relevant to anything? Could be true, could be also not true. Let's assume R true, right? If R is true, then P is true. Both statements made by the woman are true. Neither one, so these two cannot be true at the same time. Exactly one statement made by a man is true. So therefore Q, R, and T. So this is true, this is false, and this is false. And I've somehow managed to make this work. Okay, P statement is true. Of these 5 statements, an odd number is true, which does compute. Neither, so both women are lying. Both statements made by the women are true, which is false. Exactly once. Okay, that's false. Okay, let's try Q. Right? Let's try Q is true, which means only exactly one of them made by is true, which means T must be false. Which means that R and P. So it all depends on P. So this is currently false. So this is false, and this is false. And if this was true, then this would also be true. And yeah, so it'd be definitively false. So this is not a valid solution. Okay, so now let's just look at S, right? Let's say S is true. Let's say Q is false. Say T is false. And that's already breaking the rule because we need it to be 4 true in order for it to make a difference. So it's probably D. That's what we're concluding. Okay. So 20 times 3, so yeah, we're ahead of schedule. So let's go back and let's look at the weird questions that we got wrong at the beginning. Let's look at question 3. I put a marker here. So I did manage to figure this out. I subbed them in. That's what I did. I subbed them in. So I subbed -4 in the original. And that produced 1, which is not equivalent to -1. Because this always produces the correct and the positive answer. And I subbed -1. And that produces 2. And I subbed -1 here, which produces 2 also. So 2, 2. So one of them is correct. And the incorrect solution comes from somewhere. And since we can pretty objectively verify 2 to be true, and 3 to be true, right? We can therefore conclude this one. Okay, I'm not spending more brain power on this. I'm going to say it's correct. Let's go back and look at 1. 1 is the radius of the circle, which is this mess, which we're crossing this out. So we were here. We rearrange, take the 2 out, and then we divide it by 2 again, in order to complete the square, and then it's minus 4 and minus 9, and we'll multiply by 2 because we kind of have to, and then we add them together, which is valid. We fling it over there, it's 11, divided by 2 because we have to get rid of the 2, and square root the thing in order to get radius, which is fine. Yeah, okay, that seems valid. Yeah, okay. Let's move on to question 2. Question 2 is the gradient of the curve, which we multiplied, which we expanded in order to get that, which looks correct. And then we divided each term in order to get this very not pretty item, which we then do we subtract correctly? Subtract, subtract, subtract. Yeah, these subtractions look correct. These multiplications look correct. Do they? Yeah, they do. Yeah, okay, these multiplications look correct. And then we put in square root of 2, which also looks correct. Haha, I spotted an error. So, this is actually not. Okay, yeah, so this is actually wrong because this is actually, so it should actually be 2 squared, 9 minus 3 minus 6, because we canceled this out by accident, and then, so therefore this is 12, 2, so these 6, so it is actually 6 square root of 2, which is E, so that's the correct answer, it's not D. Moving on, we already covered C, 3, 4 is A. Every card which has a vowel on its back has an even number on its back. And A disproves that because it has a vowel but has an odd. So yeah, there we go, it's A. Using the observation that this equals that, um, yeah, okay, so we can write this as 2, and so the log of 3 when it is 2 is 3, and yes, this does in fact compute, so there we go, yeah, it's A. I don't know what to say, it's not that hard. It's not that hard, gang. So 80 needs to be as small as possible. We need to maximize x. So 80 needs to be as small as possible, and the area needs to be the biggest possible. And we have done that both correctly, so I'm going to move on. I don't think there's too much to this. If I get this wrong, I'm going to crash out. So, we subbed in x equals 0 and y equals 0 on both counts. And we made sure that everything went to 0, so it's just y cubed for both. Y cubed or x cubed equals 1. And so therefore, it's always 1. And so it's C. Okay, that seems correct. 8. Oh, this is weird. So what we've done here is we multiplied the entire thing out. Did we do that correctly is the problem. 1 plus 2n, yeah, 1n plus 2n equals 3, multiplied that equals 2. So what we did here was we added n to all of these, and then we multiplied all of these by 3. So, yes, that looks correct. We added these two together, we added these two together, and we got this. Multiplied that entire thing by n, and so therefore we could conclude that. So since n equals 1 works, and n equals 2 doesn't work, we can therefore conclude that screw C, screw D, screw E, screw A, so it's probably B. That was the conclusion we made. Make sense? 9E. Someday next week, every day next week, Fred will do at least one math problem, which means that if it's not true, on some day next week, he will do no math problems. That sounds right. I don't think there's anything here to think about. This stupid fucker. So, sub it in. Shocking. That is correct. And since we've already crossed out C, because as x goes up, y goes down, don't it? Yep. So, therefore it can't be C, therefore it's E. Because all the other ones are like off in the middle of nowhere. Yeah, that looks right. Okay, moving on. Which of the following is largest by a value? So 10 is, yeah, so 10 is in fact, oy, oy, oy. 10, it looks like this, where this is pi over 2. So therefore, if we run a nice graph, it's bound to be negative, so it's not going to be 10. Log 1000 is 2. Sine, that's just a fraction to the power of 10. That's another like that's not a fraction, that's irrational, but that is lower than 1 to the power of 10. So therefore it's D. There we go. So we've written D. Yep, great. This is the one that I really didn't like. This is the memorization one, which I didn't remember. Factor theorem I got right. I just don't remember the remainder theorem because I don't think it was in my example GCSE. Ah, oh, my brain and my bones hurt. Right, so two. You know what? There's literally no benefit I could do from looking at this further. Right, so everyone beat George. There were no ties. Everyone beat George. Right, because Hermione also beat Lavender. So Hermione could be here or here or here. Or Lavender could be here. Wait a minute. What if it's not six? What if it's okay? So what if Lavender's here, Hermione's here, and there's also two? Shit. Okay, so it's definitely not six. So okay, let's re-examine this. So Lavender is at the bottom. Hermione's here. There are two possible solutions for this. Two possible solutions. So it's two plus two. So it's six, right? So that's six because there are two possible positions for the whatchamacallit. So here there are two possible solutions. Two possible solutions, so it's plus 4. Finally here, money must be here, here, so it's like gotta be Fred here, or it could be Big Man around here, or it could be Big Man around here and Fred there. So this is plus 2, so therefore it's equals 12, so therefore it's C. Right, okay, that seems more reasonable than this. Let's go and move on. I wrote B here because I didn't know the answer. Uh-oh, that's not good. I should know the answer to these. I have 11 minutes. That's fine. So we figured out it's not D, right? It's not D. It's not A either. So it's B or C. And since A is true, and A has an extrema has an even number of extrema, we therefore concluded C was probably more likely to be true, and so we picked out B as being the outlier, and we took that out. Is this true, however? I'd say yet to be confirmed, but you know. Because I don't think I can use a practical example in order to figure this out. Let's check the calculations for the rest of this and then come back to this. I don't think it's that important. Yeah, we can afford to lose a mark to two, you know. Okay, right. One is definitively true because you can fling that over and fling that over, so you can basically reverse them without changing the inequality. Three is a bit fucked. Because if c is negative, then that entire thing flips over. Then that thing just isn't true. And finally, that can be factorized, and it is most definitively true because it's equal, and so therefore it's 1 and 2. Okay, fine, that makes sense. Oh, this is the weird one. Oh, fuck. Why are all these weird? Slimy and weird, right? Sure. A1 equals 2, A2 equals 1. Because it goes up and down, so the permutation is not going to be that much. It's not going to mutate by that much for each term, is it? And we're adding together 100 numbers. So it really should go. So it really should be A. I don't know. Like, it really should be A. I don't know. Wait, this one was the relatively easier one. For some positive factor m, there's no number in S. There's a factor of m. Yeah. So I don't think they're gonna try and trip you up on the wording. So I can just pretty much conclude that's correct. It's not 20. So all I need to do is verify that this works. So it does work here, it does work here. So the mean is 0, and the range is in fact 20. So yeah, I'm just gonna skip this. I don't see much point. And you were back. I put G because I didn't know the answer. Which one do I want to work on? 14 or 19? I feel like I've been working on 19 too long. So 14 it is. Let's go look at it. It's this mess. It's some A, it's some D. Got no clue, man. So, okay, A, B, C, D, E, F. This is a quintic. The graph is two local minima and two local maxima. It's correct. Okay, let's engage with this problem actively. Let's try and graph it somehow. Even though this isn't really something I would graph normally. So it does preserve the, yeah, so it does go up from here. So 1, 2, 3, 4, 5. So it's something like that. What we're looking at is something like this is possible, right? It's a minimum, x maximum. Yeah, I can't help but feel like it's B. Right? Like this makes sense. How are you supposed to? Okay, let's see if we can use this graph to create. No, you can't, because it has to be a point of inflection if two of them are involved. So it has to become this, right? Am I dumb? Yeah, no, this seems right. Okay, fine. We're concluding 14 is correct. If it's wrong, fuck it. It's one question. Let's get rid of this one right though. So it's either we work on this or we work on which one? Sort this out. We work on is 10. Is 10 the odd one? The 10 we got 9? No, 9 we got 3? No, 3 we got. 16, is that it? 16, 16 is a weird one. Okay, so I have a very low chance of scoring 20, or of 19, or yeah, let's just go work on 19 for the last 4 minutes. It doesn't really matter at this point. The positive root numbers, the equation, blah, blah, blah. Actually, no, let's verify 20 first. Um, let's see. R, so we just need to prove that it's not 4. Oh, wait, there are options. Nah, those don't matter, do they? No, no, there are options. Those do matter. Okay, so of these five statements, an odd number are true. Yeah, it could be 2, right? Oh my God, yeah, because Mr. P could just be wrong. Mr. P could be wrong. It's like an on-off switch. It could be on or it could be off. Oh yeah, yeah, it's cool. Yeah, okay. Okay, so I'm guessing it's H. Fine. Actually, no, let's verify the actual math first. Exactly one statement made by a man is true. Fuck you. Q, both statements made by women are true. No. My first name is Robert, and Mr. P's statement is true. Okay, never mind. It's not gonna be H then. Okay, that's thank God. Okay, let's put it back as D. Who? What was T? Okay, so it has to be at least one. You'd have to be okay. I'm trying to figure out a way if there could be four of them true at the same time, right? So if Mr. T is wrong because he's a misogynist, Miss Q is correct, Miss S is correct. Then no, that caps it to only three. Okay, never mind. So let's go back to 19. That's a hard one. Okay, so which of the following correctly describes the real roots of the equation da blah blah blue? Uh wait. No, but C could be positive or negative, so it doesn't matter. It could be shifted up or down. Ah, wait, or is C always? No, we know that for a damn fact C is positive, so it has to be shifted up, up, up and away. But that doesn't help things at all. That doesn't get us anywhere. Okay, never mind, fam. I'm really interested in looking at the solution to this. So we ruled out B and E. Can we rule out more? I want to rule out one more, just so I can feel safe about it. It has three real roots, but their signs differ depending on A and B and C. It has exactly one real root, which is negative. No, because everything we know about this equation is derived from the fact that it's this specifically, right? Should we have expanded this? I think we should have, but got to buy no. Right, TMUA is done. That was tiring in the extreme. Um, okay, so let's stop looking at OBS. I've just clicked the wrong buttons repeatedly. No, okay, let's go and take a look at YouTube. Let's see if anyone actually showed up. By the way, this is a completely fresh YouTube account. So yeah, let's see if anyone showed up. I think. Yep, no one showed up. Yay! So, yeah. What are we doing now? Checking the answers, aren't we? Right, so, that's the wrong thing. Early specimen paper, answer key. Worked answers. Okay, let's just rapidly go through everything and mark them off first. Just see how much of this we've gotten correct. This off? Right, okay. Okay, I would have been really embarrassing if I got question one wrong. Option five. There is no way. There is no way. There's no way. There is no way. There is no way. Okay, so we've gotten it wrong because we got the final last step, and then we proceeded to fuck up the last step because I can't divide things. Apparently, that's just not one of my key skills. Let's go. Okay, the correct answer is C, so I did guess that right. The correct answer is A. I did guess that right. I didn't guess that. Okay, that was pure skill. A, that's correct. It's F, that's correct. That's C, that's correct. That fine. Let's see. Okay. So it's E, that's correct. So far, so mediocre. E, that's correct. D, that's correct. Am I the right question? Right. D, that's correct. A, that's correct. Okay, okay, okay. C, that's correct. B, that's correct. Oh my days. E, A, both correct. E, correct. What? It is correct. Oh my days. Okay, so it's just B. Fine. B was one of the ones scratched out. Oh, that's lame. Right. Option D. Yeah, we got the final question correct. Okay, that's all I wanted. That's all I wanted in life and existence is just to get the last question correct. I mean, to be fair, it was a pretty easy last question. Much easier than 19, in fact. So I got one wrong. I got one wrong and I got one wrong. So I got 17 out of 20, which is actually a pretty decent score. I'll take that. That's 85%. That's like a 9 in GCSE terms. So we'll take it. We'll take it. It could be worse. I will say though, I have no idea how I got any of these. Okay, I have some idea how I got this wrong, but I have no idea how I got 19 wrong or 8. 8 is odd, isn't it? Right, 8 is the question we were yamming about, so we could seriously just plug in some numbers, right? Are you serious? Did I just multiply this wrong? Yeah, I think I just multiplied this wrong. Is it a sum? I can't read. Is it a sum? It's a sum, isn't it? Ah! I don't know what the difference between a sum and a product is, right? So reading is quite essential. It's quite essential life skill. Reading is always the hardest part of a math exam. This is division, moron, baka, and question 19 is genuinely a flaw in understanding. So let's go and look at that. That will be much more interesting to look at than the rest of these awful questions, right? Our first equation can be rewritten. Second equation has been rewritten. We can see that it's negated. We can negate. Ooh, we can negate it to find this. Ooh, that's some fancy techniques right there. Oh, so that's some cool algebraic manipulation. So what you gotta do is just you gotta write this out, right? So I did that get to do the first step correctly. So what you gotta do is you gotta write this out. Just okay, and then we can see that constant and x squared have been negated, and then you negate the entire thing in order to do it correctly. Yeah, okay. And then, okay, and then you negate this, right? So now we can see that the differences are in x squared, the x cubed, and just b of x. This indicates we can relate this to equation 1 by substituting a number. We find... Oh, so you can sub the thing in. Hmm. Oh, okay. So, actually, it's not 0. I mean, no, it is 0, right? It is 0. But this is f of x. This is g of x. This is negative g of x. And so, therefore, since these two are the same, yeah. So since f of negative x, if you plug in a negative x, this becomes this, equals g of negative x, which also happens to equal 0. So then f of x equals 0. Because it doesn't matter if this is negative because it's on 0 anyways. So then we can figure this out. Yeah, so then we reflect it in the y-axis and it becomes, oh, okay. So that's how you do it. So the handy little trick here is that you figure out, you have to do some algebraic manipulation. You have to negate it, sub in negative x by noticing, by noticing like powers when x equals negative, f of x uh, are equivalent to g of x. Okay, I failed to consider this as a function, really. I didn't consider this at all in a function. You see there's no function notation here. Instead I tried to consider this, numerically, slightly more numerically, which didn't really work out. So yeah, it's a useful thing to keep in mind. You can mess around with the numbers and the letters and generally get a better result. And then this is just a common reading L, which is, I guess, fair. I mean, to be fair, the method was completely correct. If only I had, read it wrong. And this was just, you can't divide, moron. Yeah. Okay. So I think the lesson to be learned here is that Double checking it twice is quite good. Reading errors are quite prevalent, and here is just a problem of doing more past paper questions and realizing what the correct method is. So yeah, I would say overall I'm pretty happy. I'm pretty happy with this result. But again, this is one of the easier specimen two papers. So in the future, we will have to lock in. We will have to deliver better results, and that is pretty much all for next time. So next time, I don't know when I'll stream next. Perhaps I shall do so tomorrow. Maybe I might do a little more research into this whole YouTube thing. Once I figure out what I'm doing, I suppose schedule my screen. I'll schedule my stream a little earlier so that some people can get some notice. And that's pretty much all. Okay. Thank you for not watching. I hope. Okay. Thank you for not watching, and I'll see you next time. Possibly. Okay. How do I?